The leave plan of room specialists has revealed that utilizing our new 101 billion toy, it will likely always be before that. If all goes according to plan, the trip to Proxima B is expected to take about 20 years. However, realistically, it will likely be a few years before we can even begin to confirm whether there is any life on that planet. The ongoing inquiry into whether we are truly alone in the universe persists, fueled by discoveries from the James Webb Space Telescope. This telescope has already found some incredibly intriguing phenomena far from Earth that might bring us closer to answering this question. Our quest for understanding our place and significance in the universe has always been central to human existence, generating countless media productions and theories over time. Our curiosity about the universe, along with our sense of loneliness, has driven us to constantly search for others. Even if we are minuscule in the grand scale of things, we might be drawing nearer to the answers we seek. But are they really the answers we want? Or are they simply unsettling revelations? Join us as we explore the latest findings in the field of systems and exoplanets, as we embark on a journey that may lead us to encounter something we are not ready to understand. In 2021, experts made a significant breakthrough, potentially one of the greatest discoveries in history, with the launch of the James Webb Space Telescope. A fascinating hypothetical question was raised regarding the capabilities of our technology. The question was whether, in the future, our telescopes could detect artificial light on another planet, such as Proxima B, the closest exoplanet to Earth. Proxima B, located 4.25 light-years away, was identified as having a permanent day-side and night-side, similar to our moon. A hypothetical advanced civilization on Proxima B might harness energy from the day-side and transfer it to the night-side using photovoltaic cells, which convert sunlight into power. In a paper co-authored by Manis Ving and other scientists, it was demonstrated that an extensive array of solar panels on the day-side could be linked to future telescopes. Since the James Webb Space Telescope, JWST, has been upgraded, it has enabled us to extend our search for artificial lights on exoplanets like Proxima B. The fact that the JWST was able to detect these lights in 2024, with its enhanced capabilities, marks a revolutionary moment. The JWST may have located the very lights we've been searching for, potentially propelling us into a new phase of human exploration. Let's dive into the world of planets and exoplanets to understand how this discovery became possible. Since the dawn of written history, humans have pondered the vastness of the universe. Who are we? Where do we come from? And where are we headed? These questions are timeless but also exceedingly complex. As we continue to advance technologically, one wonders whether we are any closer to answering these questions. If you were to ask a scholar, they might claim that we are still at the very beginning of understanding our place in the universe. However, ask an astronomer the same question, and they'll likely become enthusiastic, eager to share the latest findings made about the universe through the use of their advanced instruments. These tools, which are often overlooked by the general public, are in fact a direct reflection of human progress. We now have access to the universe, and it's time for us to push forward and harness the knowledge and technology that brings the cosmos within reach. One such advancement is the creation of the James Webb Space Telescope, JWST, which holds the key to answering some of the most fundamental questions humans have about our existence. The James Webb Space Telescope represents humanity's efforts to explore space and seek answers to age-old questions. Are we alone? What is our purpose? And where are we going? This powerful infrared telescope is already working to address these questions. But if you're wondering about Proxima B, it is sometimes referred to as Proxima Centauri B or Alpha Centauri B. This exoplanet is a super-Earth and orbits an M-type star. You might be puzzled by the term super-Earth, but don't worry. This article will clarify everything. Super-Earths are planets that are larger than Earth but smaller than gas giants like Neptune and Uranus. They can consist of gas, rock, or a combination of both, and their sizes range from twice the mass of Earth to several times that of our planet. Proxima B is a super-Earth exoplanet, meaning it orbits outside of our solar system. The first hints of exoplanets emerged in 1917, but it wasn't until 1992 that the first confirmed discovery left experts astonished. Another exoplanet, initially discovered in 1988, was confirmed in 2003. As of April 1, 2024, There are 5,653 confirmed exoplanets in 4,161 planetary systems, with 896 of those systems hosting more than one planet. Many of these exoplanets orbit around M-type stars. To understand M-type stars, it's essential to know that they are the smallest type of stars in the main sequence, often referred to as red dwarfs. These stars are incredibly common in the Milky Way, but their faint glow makes them hard to detect. M-type stars have temperatures around 3,000 Kelvin, which is relatively cool compared to other stars. Proxima B's host star, Proxima Centauri, has a mass roughly equivalent to 1.07 times that of Earth. Interestingly, Proxima B only takes 11.2 days to complete one orbit around its star, which is much shorter than Earth's 365.25-day orbit. Proxima B's star is quite faint, emitting only about 1.6% of the Sun's total luminosity in the visible light range. Its radiance is even lower, producing only 5 to 6% of the Sun's visible light output. Over 85% of the energy emitted by Proxima Centauri is in the form of infrared radiation. Proxima B orbits the star at a distance of about 0.045 to 0.056 astronomical units, much closer than Earth is to the Sun. Proxima B was first discovered in 2016. You might wonder why this exoplanet, despite the existence of millions of other stars, planets, and galaxies, has garnered so much attention. There are a few key reasons for this. First, Proxima B is the closest known exoplanet to our Sun, located just 4.2 light-years away. While 4.2 light-years may seem like a vast distance, it is relatively small in the context of the entire universe. Proxima B is part of the Alpha Centauri system, a triple-star system. Despite Proxima Centauri's faint luminosity, the Alpha Centauri system remains one of the brightest objects in the night sky, coming in just behind Sirius and Canopus. Perhaps the most fascinating aspect of Proxima B is that it may be habitable, as it lies within the habitable zone of its star. This zone is where liquid water could exist, raising the possibility of life. For these reasons, astronomers have been keen to explore the potential habitability of Proxima B and other exoplanets like it. This is where the James Webb Space Telescope comes into play. The JWST has 4 key objectives: to study the light from the first stars and galaxies formed after the Big Bang, to investigate the formation of stars and planetary systems, to understand the development of stars and planets, and to explore the origins of life. As the JWST continues to explore exoplanets like Proxima B, we are moving closer to achieving these goals. From searching for exoplanets to investigating extraterrestrial life, this quest is not merely about answering scientific questions. It's also a reflection of human curiosity. Throughout history, humans have been driven to explore, to seek, and to understand everything in our universe, both animate and inanimate. This insatiable curiosity led to the search for extraterrestrial intelligence, SETI, an effort to find signs of life beyond Earth. SETI is one of humanity's most ambitious endeavors, likened to a game of cosmic hide-and-seek, with our planet searching the vast universe for any sign of intelligent life. The search for extraterrestrial life began in the 1960s when astronomer Frank Drake first detected radio signals from stars. Although this momentous discovery did not result in any contact with extraterrestrials, it marked the beginning of a significant effort to find such signals. Despite the challenges, the search continues, and recent advancements in technology, such as the JWST, are bringing us closer to potential breakthroughs. As the James Webb Space Telescope continues to monitor exoplanets like Proxima B, there is growing hope that we may find concrete evidence of extraterrestrial life. If such evidence is found, it could change everything we know about life, intelligence, and the nature of the universe itself. Even if no direct evidence is found, the discovery of artificial signals or light from distant worlds would have profound implications, suggesting that intelligent life might be more common than previously thought. While the excitement of these discoveries is palpable, they also raise important questions about our reaction to such findings. How would we respond if we confirmed the existence of extraterrestrial life? Would we approach this discovery with curiosity, respect, and scientific rigor, or would it provoke fear and uncertainty? Humanity's history of reacting to groundbreaking revelations, especially those that challenge deeply held beliefs, has often been unpredictable. This leads to further moral and ethical considerations. If we were to encounter intelligent extraterrestrial life, what would our responsibilities be? What moral framework should guide our interactions with other forms of life, whether they are microbial or advanced? These questions are complex, and as we continue to explore the universe, they will likely become central to our understanding of our place within it. As humanity pushes the boundaries of space exploration, our increasing technological capabilities continue to open new doors to understanding the cosmos. One of the most exciting and transformative areas of study is the search for exoplanets, planets that exist outside of our solar system. This research has led to remarkable findings, with hundreds of exoplanets being discovered in just the past few decades. As we explore these distant worlds, questions about their potential for life, their conditions, and their relevance to the future of humanity have taken center stage. Exoplanet research began with humble beginnings, but the discovery of planets orbiting distant stars has now become a central aspect of astronomy. The first confirmed exoplanet orbiting a sun-like star was discovered in 1995. Since then, advancements in technology and observational techniques have made it possible to detect and analyze planets that were once beyond our reach. In the years following that breakthrough, thousands of exoplanets were discovered through a variety of methods, including the transit method, the radial velocity method, and direct imaging. These discoveries have provided invaluable insight into the nature of planetary systems, the diversity of worlds beyond our own, and the potential for habitable environments. The search for habitable exoplanets, in particular, has become a key focus of space exploration. A planet's habitable zone, the region around a star where conditions might allow liquid water to exist, has long been considered a crucial factor in determining whether life could exist there. In recent years, astronomers have discovered many exoplanets in these habitable zones. Some of these worlds are rocky with similar characteristics to Earth, while others are gas giants or ice-covered planets. While the majority of these planets are not necessarily ideal for life, the search for an Earth-like exoplanet remains one of the most exciting prospects for future exploration. The James Webb Space Telescope is poised to play a pivotal role in this search. Equipped with the most advanced infrared capabilities ever seen in a space telescope, JWST allows scientists to examine exoplanet atmospheres in unprecedented detail. This includes detecting the presence of gases like oxygen, carbon dioxide, and methane, which could be indicative of biological processes. As the JWST begins its mission, researchers are eagerly awaiting new data that could help answer some of the most profound questions humanity has ever asked. Are we alone in the universe? What does life look like on other worlds? What would it mean for us if we found evidence of life beyond Earth? Beyond the search for life, the discovery of exoplanets offers us the opportunity to learn more about the formation and evolution of planetary systems. By studying the conditions under which planets form, scientists can gain insights into the processes that led to the creation of our own solar system. Additionally, the study of planetary atmospheres, compositions, and climates helps us understand the diversity of planets and moons across the galaxy. This knowledge is not only essential for understanding the universe around us, but it could also provide the keys to future human exploration of distant worlds. One of the most pressing questions in the field of exoplanet research is whether or not these worlds could be colonized. As Earth faces challenges like overpopulation, climate change, and resource depletion, the idea of finding another habitable world has become increasingly attractive. However, while the notion of colonizing an exoplanet is captivating, the reality is far more complicated. The distance between Earth and even the closest exoplanets, such as Proxima B, poses a significant challenge. A journey to Proxima B, for instance, would take decades with current technology, and there are numerous obstacles to overcome before human settlement on another planet becomes a reality. In addition to the logistical challenges, there are numerous ethical and moral considerations regarding space colonization. Should humanity seek to inhabit another planet, we must carefully consider the potential consequences for that world. What responsibilities would we have to the environment and potential life forms on that planet? The history of human expansion on Earth is fraught with exploitation and destruction, and these lessons must be applied when considering our role in other parts of the cosmos. There is also the question of the impact on our own species. Would space colonization provide a solution to Earth's problems, or would it simply create new challenges and inequalities? Another important consideration is the potential for contact with extraterrestrial civilizations. The discovery of intelligent life beyond Earth would be one of the most profound events in human history. It could open up new avenues of communication, cultural exchange, and scientific collaboration, but it could also introduce challenges and risks. For centuries, humanity has looked to the stars with a mixture of hope and fear, imagining the possibilities of encountering extraterrestrial life. If we were to make contact, how would we respond? Would we welcome these beings as allies, or would fear and misunderstanding shape our reactions? In addition to the discovery of life, the technological implications of exploring exoplanets are immense. The challenges of interstellar travel are beyond our current capabilities, but breakthroughs in propulsion technologies, such as nuclear fusion and antimatter engines, could one day make it possible to reach distant worlds in a fraction of the time it would take with current technology. Advances in robotics, artificial intelligence, and life support systems would also be necessary to ensure the success of long-term space missions. As we continue to develop these technologies, we must also consider the ethical implications of using them to explore and potentially colonize distant worlds. The exploration of exoplanets and the search for life beyond Earth are not just scientific endeavors. They are deeply philosophical. The questions that drive this research touch on the core of human existence: our place in the universe, our origins, and our future. As we look to the stars, we are also looking inward, examining what it means to be human and what our responsibilities are to the planet we call home. In the coming decades, the discoveries made by telescopes like the JWST will shape our understanding of the cosmos and our role within it. These discoveries may bring us closer to answering the age-old questions of whether we are truly alone in the universe, and if we are, what our place in the vast expanse of space should be. The exploration of space also offers profound insights into the nature of life itself. By studying the conditions that might support life on other planets, we learn more about the resilience and adaptability of life on Earth. Whether it's the extremophiles that survive in the most inhospitable corners of our planet or the ecosystems that thrive in the depths of the oceans, life on Earth has proven to be remarkably diverse. This diversity offers hope that life might exist in forms beyond our imagination, and that the universe may be teeming with possibilities we have yet to discover. As we continue to expand our reach into the universe, we must also recognize the value of preserving and protecting our own planet. Space exploration is not just about finding new frontiers. It is also a reminder of the fragility of our own world. The same technologies that allow us to explore distant exoplanets can also be used to address the challenges we face here on Earth. Whether it's using satellite data to monitor climate change or developing sustainable energy technologies inspired by the sun, space exploration and environmental conservation are deeply connected. By exploring the stars, we gain a deeper appreciation for the unique and precious nature of our home planet. In the end, the search for life beyond Earth is not just about finding answers. It's about exploring the unknown, expanding our understanding, and pushing the boundaries of what we thought was possible. As we look toward the future, we stand at the precipice of a new era of discovery, one that will continue to shape the way we view ourselves and the universe around us. The journey ahead may be long and uncertain, but it is a journey worth taking.